Hello, Zalalam from 2620 is active. Today we will continue working on our calculator app, and today we are going to create a method to parse our expression. But before that, if you are new to my channel, please subscribe, and if you like my videos, share, comment and like. Before we go to the method, let's have two variables of dynamic type and initialize them as empty lists. So this will be holding our operator of the addition, subtraction and so on operators, and this one will hold the expression converted into postfix notation. So what we are going to implement in this is, if you go to the Wikipedia shunting yard algorithm or Dijkstra's algorithm, you will find how to parse a mathematical expression, and this includes all mathematical operators, but for our purpose we will use number, decimal numbers and the basic operators, the four operators, and it tells you what to do when you find a number, and if you find a function, that means a mathematical function, what you do when you find an operator, what you do, it tells you. Okay, so based on this guide, we will create a very simple method that will parse our method. So what we are going to do is, let's say void evaluate expression, and let's give it an expression. So here we are going to evaluate the expression. So based on the guide, what we are going to do is, while let's first initiate an integer variable called len, and it will be initialized to 0. Okay, so then what we are going to do is, while len is less than x length. Okay, so that's how we loop through the length. So at the end we are going to increment the length variable. Okay, so what we are going to do is, if we find a number, let's use only the double type, and let's say double try parse, and then we will use the symbol that we have found. Okay, is not is equals to null, because in Dart every item is considered as an object, and we can check that one, or we can find also the decimal point. So we can say ax len is equals to dot. Okay, so what we are going to do is, let's define another variable called string token. Okay, let's initialize it to be empty. Okay, so here what we are going to do is, we are going to add the character or string at an index of len to the token and assign back that value to token. Okay, so that's what we do. And if the item that we find here, we are going to use else if, and if the item that we are going to find is for example an addition operator. Okay, an addition operator. So if it's addition, that means we have collected a token and we have to change it to a number. Okay, so what we have to do is, we have an output list that we have defined there, so we will add the token to the output. Okay, we add it to the token. Okay, we add the token, then we have to empty the token. We already used it, so we have to empty it, so that we will use it again in the loop. Then we have to check that before we add the addition operator to our operators list, we have to check whether the operators has any operator, and if the operator is must be evaluated before the plus operator or it has the same precedence, then we have to take it to the outputs list, and then we will add the addition to the operators list. So what we have to do is, if operators is not empty, okay, it should not be, is not empty, and then we have to have in the operators, okay, here we are going to the last one, okay, is equals to minus subtraction. It has got the same precedence as addition, or we are going to add another one. We have to have this one, or we have to add division or multiplication. So we want to make it multiplication. When it is entered in the expression, it will be like x. Okay, so if we have found this one, what we are going to do is we are going to add outputs, add here, we are going to add the last index operator here. Okay, since we are going to try it with a simple expression, we will do this one. Otherwise, we have to use a while loop here, so that if there are same kind of operators next to the last one, then we have to put it on outputs, remove from the top of the operators index, and evaluate the next one. So we will do that one. Then at the end, once we have done that one, we are going to add, okay, so we add this one. Okay, so this is pretty similar with the other operators as well. Okay, if it is subtraction, we do here the addition, multiplication, and division. Okay, the same kind of operation. Then we will do for multiplication. Okay, so here the same precedence is division, so what we are going to do is check only division and remove the others. Okay, so we will remove the others. We only need to check for division. Here we will do the same for division. Okay, if it is division, we have to check for multiplication. Then it's the same thing. Now, once we are done, if you can imagine an expression, at the end of the length of the expression, there will be a number. Okay, so if you write here 2 plus, okay, 3, then at the end we are going to evaluate a number. So because there was no operator, we are going to leave the last operation or the last expression without being added. So we have, what we have to do is, if len is equals to, at the end of the expression, length, then we have to add the token, okay, here, and we can empty the token or leave it alone because it is the end, doesn't matter. So here this will change the infix the expression to a postfix expression. So that means we are going to make the operation as 222 3 and then plus. Okay, so what we are going to do is the method will change. For example, 222 plus 3 times 5, this will be changed to 222, and then we will have 3, and then we will have the addition, and then we will have sorry, then we will have 5, and then we will have the multiplication, and then the addition. Okay, so that's how the postfix notation will be. First we will multiply this one, and then we will add both. That's how things will be changed. So good, this will create our postfix notation. Then we will add another method to evaluate the mathematical expression. So it's better to say this one, the function infix to postfix. That's better because the function of this method is to change this one. The second method will be expression, and in this one we are going to have list of postfix notation, and we are going to evaluate that one. So to do that, what we are going to do is we will use a while loop. Okay, while. Okay, here as well we have to define index. Okay, which starts from 0, and then we will say index is less than list pf length. Okay, so while we are parsing through the list, if we find addition operator, so that means we have changed the postfix, the infix to postfix. So if we find the first one addition, then what we are going to do is let's discuss it with multiplication. If you find this one to be addition, then what we are going to do is we are going to add 3 and 5. So what we are going to do is double sum is equals to pf index minus 1 plus pf index minus 2. Okay, so this is the sum. Then what we are going to do is we are going to remove these items, and then add the sum in place of the minus 2 index. Okay, so what we are going to do is pf is equals to sum. Okay, we'll put that one, and then what we are going to do is pf remove. So here remove add, it's going to be index. Okay, and then we will repeat this one, index minus 1. So we have changed the minus 2 index to be sum. So at the end we have to change the position of index to minus 2 position. Okay, and then we will pass index is equals to index minus 2. So then we will start from that one. So this is the same operation for all of the operators, and we expect the so at the end of the evaluation we expect output the pf to have only one value. Okay, so here we will do, if this is multiplication, we are going to do multiplication here, and we will call it product. Okay, so if it is subtraction, we are going to do sub, and here we are going to assign sub. Okay, and if it is division, since this is a simple calculator, we are not going to check for zero division error. We can do that, but for simplicity we will calculate the quotient assuming that the provided expression is valid. Okay, so here at the end of the operation we expect these methods to be operated by the equal to one. We can do it with the text changed event of the text editors, but for our purpose we will use the equal to button. Okay, the equal to button. So here we have added the elevator button compressed method. We will say, if, okay, the label values index to string is equals to this one, we are going to do infix to postfix, and here we are going to add expression. Okay, so this one will infix to postfix will create postfix notation of output like this. Okay, then after that we are going to evaluate. What did we call the method of evaluation? Eval maths. So this is, we have made a mistake of including the method in a method. Okay, so we have to put it here. That's why we cannot access it. So here we will say eval ex, and then we will provide it outputs. Okay, so once the output is, what did you call the method again? Expression. Okay, so that should be right. So we do that. Then we will set the results text controller. Okay, results text controller. Here we have got the results text controller for the result. Here result controller text is equals to outputs length -1 and to string. Okay, we have to change it to string. Okay, so that's it. So else we are going to do the expression thing. Okay, the others do the expressions. So if we do this one, what will be the result? Let's hard reload it.
So we had an infinite loop, so because we forgot to increment the index variable in the expression evaluation, and we had to also correct the value of the items we operate on from the output list, because it's a dynamic list, so we have to convert it to a string format, and we need to also update the operators list at the end and at each step of the operation. After adding the operators onto the output dynamic list, we are to remove the top one, and to make it complete we have used the partial part of the algorithm that is described in Wikipedia as the shunting yard algorithm, or it's called Dijkstra's algorithm. The algorithm described here includes parentheses and also a function that is functions like trigonometric functions like sine, cosine, and so on are also included. But for our purpose, we need only the four operators, simple one. Our main purpose is to demonstrate how to use a grid view control in Flutter, so we have seen that one. So here we can demonstrate that this calculator can work on those applications. How now it's running, and if I do 2 plus 3 times 5, we expect the result of multiplication first and then addition of the product and 2, which is going to be 17. Okay, so we have got 17, right? We were able to parse the simple expressions that we want to enter. Okay, we can also work on a more complicated equations as well. If we add the equation, for example, 9 divided by 3 subtract 1 times 5, we expect the division and the multiplication to be done first. So this one is 3 and this one is 5, and we expect minus 2 as a result. Okay, so here we have got our result. As you can see, this is a postfix notation produced by the infix postfix function. Okay, and then at the end, the operators in the operators list is this one, and it will be at the end of the loop, it will be added to the output here. As you can see, at the end, after finishing the parsing, if the operators list is not empty, we will add these ones starting from the top of the list to the output folder. Okay, so that's how we use grid view in Flutter. Thank you for your time.